question. A particle was moving along a straight line. The acceleration of the particle after t seconds was given by, let me use a highlighter here, was given by 9 minus 3t meters per square second. The initial velocity of the particle was 7 meters per second. Find the velocity of the particle at any given time. The velocity of the particle at any given time. Now, this question is asking us to come up with an equation of velocity. We have already been given acceleration. So, what we need to is to use acceleration to get velocity. Now, SVA, let me use a different color. From acceleration to this direction, I'm going to integrate. From that to that direction, we're supposed to differentiate. So, for me to get velocity, that means I'll have to integrate the acceleration function. Okay, so velocity is equal to the integral of acceleration with respect to t. Now note that here we are using t as our independent variable. So the integration will be with respect to t, not with respect to x. Now, for us to make sure that we are doing it with respect to t, then for us to make sure that we are doing the integration with respect to t, we have to bring that here. We have to do the substitution that way. We have to bring all of this equation, all of this function, and substitute here. And after doing the substitution, now the integration process can proceed. Now, you see, this is what has happened. This is the substitution. We have substituted the acceleration function. Now, next is to do the integration process. The integration process is as follows. Now, you can see 90 t raised to power 0 plus 1. Why are we saying t raised to power 0? Because 9 was just there alone. And we need to know that anything that is raised to power 0 is equal to 1. That's why we are including t power 0. Plus 1 over 0 plus 1 minus 3t, because t alone is just the same as t raised to power 1, plus 1 over 1 plus 1 plus an arbitrary constant. Now, let us see what it brings us to. It brings this. V is equal to 90 minus 3t squared over 2 plus arbitrary constant. One thing to note here, we have to know what this is. We have to get the value of this arbitrary constant for the velocity to be, for the velocity function to be complete. And now we're going to arrive at that. Now that we have already been given the initial conditions, the initial conditions are the value of t is 0 and the value of v velocity, initial velocity, is 7 meters per second. Then doing the substitution of those values, whereby in the t we substitute 0 in the t, and we substitute 7 in the v, and That is the substitution. That is a substitution. So where we have t, we substitute with 0. Where we have v, we substitute with 7. And then after doing the substitution, the value of c is 7. And now we can comfortably replace the value of c, with the 7. With the 7. And the equation now is complete. The expression is complete, and that is the expression for velocity. Velocity is equal to 90 minus 3t squared over 2 plus 7. Let us go to the next part of this problem. Find the maximum velocity of the particle. Let me use a highlighter here. Highlighter will be important. And if we can change the color, let me use color red, which is normally very loud. The maximum velocity. Find the maximum velocity. Maximum velocity is when acceleration is equal to 0. When acceleration is equal to 0, then we say the velocity is maximum. So, but we cannot just get velocity straight away. We have to get the time when velocity was maximum. And then we substitute the time in the velocity function. So we are going to start from acceleration. So acceleration, that is the equation for acceleration. Acceleration is equal to 9 minus 3t. But we have said that acceleration is equal to 0 when velocity is maximum. So we have to equate that with the 0, like we have seen. And after equating it to 0, we ought to find the value of t as follows. So t is equal to 3 seconds. So substituting for t in the velocity function, when you substitute for t in the velocity function, you look at that, you substitute the value of t in the velocity function, we have that is the velocity function. So what we are going to do, we are going to write 3 here. Substitute with the 3 where we have t, substitute with the 3 for us to get the maximum, like as shown. So 3, and after doing the computation, we arrive at 20.5 meters per second. So that is the maximum velocity attained by the particle in motion. Let us go to the next part of this problem. Calculate the distance covered by the particle by the time it attained maximum velocity. Now, what is distance? What is distance? Let me use a highlighter here. Highlighter. What is distance? And what are we talking about when velocity was maximum? Remember that the motion started when when at the initial stage, when time was 0, and the maximum velocity that was attained, it was attained when time was 3 seconds. So now